Hi guys, let's do two more examples just to make sure we fully understand how to do this. Plus, I'm going to throw in a couple other interesting little twists to make sure that we can use Pascal's triangle accurately. So here's our second example. We did our first example in the first video. In this problem, I've upped the stakes a little bit by putting a number in the binomial and not just having two letters. So let's take a look at what happens when we have a number. In our two examples in this video, I'm going to start writing things vertically instead of horizontally because it just takes up so much space when you write it horizontally. So I'm going to go vertically instead. It's also going to help me with making sure that I keep all of my terms separated because I'm going to write them each on separate lines. So the first thing we need to do is we need to look at our Pascal's triangle, which hopefully you printed out. We're looking for row number 4. Row number 4 is the row where the second number is the number 4. Here are the numbers that are from row number 4. 1, 4, 6, 4, 1. Now, if you remember from our first video, the next thing we're going to do is we're going to take our first term, which is x, and we're going to start with the exponent of 4, because that's the exponent on our binomial, and we're going to count down to 0. Then we're going to take our second number from our binomial, which in this one is an actual number, the number 3, and we're going to start at 0 and count up to 4. Now, because we have numbers in this problem and not just two variables, we do need to do a little bit more math, a little bit more calculating before finding our final answer. So I'm going to do one term at a time, simplify it as much as possible. And once I've simplified all my terms, I'm going to write it as one long adding problem. Starting with my first term, 1x to the 4th, 3 to the 0. The first thing we need to do is figure out what is 3 to the 0, and anything to the power of 0 is just 1. And then I am going to end up multiplying the two numbers together because this is just one, well, this term is one multiplication problem. So I can multiply the first one with the last one. And so I just get x to the 4th. For my next term, 3 to the 1st is just 3. And then again, because this is all multiplying, I am going to multiply the 4 times the 3, and that is 12. Next, I have 3 squared, which is 9. And then I will need to multiply the 6 times the 9, which is 54. 3 to the 3rd is 27, and then x to the 1st, you don't have to write the 1 there if you don't want to. And then 4 times 27 is 108. And then finally, x to the 0, that turns into just the number 1 with no more letter x's. And then 3 to the 4th is 81. So now I'm doing 1 times 1 times 81, and I get 81. And then for my final answer, I just write that as a very long adding problem. We do want to keep it in standard form, so make sure you start with the largest exponent and then work your way down. Let's try one more together, and then we'll be done for today. In this problem, again, up the stakes a little bit. I put an exponent not only outside my parentheses, but also on my variable. And then the other thing that's a little bit different about this problem is that it's being subtracted instead of being added. So we'll see there's actually a really cool pattern that happens when it's subtraction instead of addition. But let's go ahead and look on Pascal's triangle for row number 5. Remember, that's the row where 5 is the second number. Row number 5 has the coefficients of 1, 5, 10, 10, 5, 1. Now we do need to keep the x to the 3rd, and then we're going to put an extra exponent on top of that. So I'm going to put the x to the 3rd in a parentheses, and then I'll put the extra exponent on the outside. We're going to start with the exponent of 5, because that's our exponent on our binomial. So the x to the 3rd stays the same, and then the one on the outside, that one counts down from 5 down to 0. For the 4, we can make it a -4, and then after we do this problem, I'll tell you what that pattern is that's happening. So we can do -4, and then we start to the 0, and then we count up to 5. Just like our last problem, I'm going to simplify this one term at a time until I've simplified all of them, and then I can make it one big adding and subtracting problem. For all of my x's, when you're raising a power to a power, you multiply the exponents together. So x to the 3rd to the 5th, I'm going to do 3 times 5, and that'll turn into an x to the 15th. Anything to the power of 0 just turns into the number 1. So -4 to the 0 is actually the number 1, and that just turns into x to the 15th. For my next term, I'm going to do 3 times 4 for my exponents, and that'll become x to the 12th. And then -4 to the first power is going to stay a -4. Notice that I kept it in parentheses so that I could still tell that it was a multiplying problem. I don't want to accidentally think that I'm doing 5 minus 4. I'm doing 5 times -4, and that turns into a -20. For my next term, on my exponents, on my letter x, I'm going to do 3 times 3, which is 9. -4 squared. So when you square a negative number, it will turn into a positive. So that will become a 16. And then I am going to multiply the 10 times the 16, and that turns into a 160. If you're using a calculator, make sure that you're putting the negative sign in parentheses and that you're putting your exponent on the outside of the parentheses. And that will guarantee that you get the correct sign for your answer. Next, I'm going to do x to the third squared. So 3 times 2 is 6. -4 to the third power is -64. Again, I kept it in parentheses so I don't mistake it for subtracting. 10 times -64 is -640. Next, 3 times 1 is 3. -4 to the fourth turns into positive 256. And 256 times 5 is 1,280. Last one. 3 times 0 is 0. I mean, anything to the power of 0 is 1. So that x is just going to go away. And that'll always happen on whenever you have that to the power of 0. And then -4 to the fifth is -1,024. And we're just multiplying that by a bunch of ones. So it's going to stay -1,024. And then we make a long adding and subtracting problem. So here's the pattern that kind of happens when you have subtracting in your binomial instead of adding, is every other term will be subtracting, a negative. So our first term is a positive, but our second term is subtracting. Then we have adding, subtracting, adding, subtracting. So you can always just make sure that that pattern happens where it goes every other one. This concludes our videos for today.